Let's now jump straight into implementing our motor controller class. We're going to use the same logic that we used for our twelfth code, which means that our microcontroller is going to be connected to our motor driver through these 4 communication pins. They'll also be connected together on their power and ground, but for this we really just need to focus on the PWM pin connected to, and of course this is the wrong diagram. We need this diagram. The PWM pin is connected to the enable pin for each motor driver. So the B enable is connected to a PWM and the A enable is connected to a PWM. So you'll need to remember those pins. Or, better yet, you can steal those values from the twelfth code. That's what's listed in this pinout file. So the left motor driver direction pin is pin 8, the PWM pin is 9, then 44 and 7. So we'll just steal those values, and I'll copy them straight over. Clearly the syntax is a little bit different for C++ than it was for twelfth. So let's define these as integers, and we'll replace the hyphens with underscores. And add our semicolons at the end. And I forgot a semicolon to close the class. There are a number of different ways we could write this interface. For the purposes of this video, I'm just going to hard code these values instead of passing them into the constructor for motor controller. Both would be perfectly valid choices. I think if you all followed my wiring diagram, which is what I would really encourage you to do, you'll have the same pin numbers here anyway. So I'm going to assume everybody that's using this code is going to have the same pin numbers, which means I am not going to ask the user to pass it into the constructor. So for example, I could ask the user to pass in the dir pin and the PWM pin, and then set those here. That's not quite the interface that we're going to have for our motor control in this instance though. Instead, our motor control class is going to be extremely simple. In fact, we don't even need to define a constructor for it because for this first video anyway, we're not going to need any member variables. So instead, we just really need our setup function and our loop step function. We'll add some additional functions later on. So for example, what should we do when we want to stop? What should we do when we want to go full speed or rotate in place? But for now, this will get us far enough. So inside setup, we need to set our pin modes. So for our microcontroller, it needs to know that those are output pins, meaning we are going to communicate toward the motor driver. We're not trying to read something from the motor driver, instead we are sending signals to the motor driver. So that goes for all 4 of our pins here. And I keep pushing the wrong buttons. So for each of these, we want to call pin mode. And for each of them, they need to be output pins. So that's our first step done. They're all output pins. We're going to be controlling them using a GPIO interface for some of them, the direction pins, and a PWM interface for the others. So we need to set those up as well. So the 2 direction pins, those are going to be our GPIO pins. And our PWM pins need to be set up as PWM pins. And one way to do that is to just note to ourselves that we're going to set the speed, essentially, on the PWM pins to 0 to begin with. And the direction, it doesn't it doesn't actually matter what we set as the initial direction. But we could do something like set them to low to begin with. And even though my spell checker doesn't know what GPIO is, I'm just going to add that to the workspace so that it learns what GPIO is. It's not just something I made up. So that's all we need to do inside setup. Make sure our pins are set to output, and then make sure they have reasonable initial values. Inside loop step, we basically just need to check one thing. If we're not enabled, that means we need to make sure we stop our motors. So we'll call stop. And it's saying stop is not defined, and that's because it's not defined. So what should stop do? It should essentially do what we're doing here, which is set the PWM values to 0, which corresponds to turning the motors off. And in fact, now that I have them defined here, there's no reason I shouldn't just initialize this with calling stop, not duplicating the code in both places. The last interface that I'd like to add to this is the ability to let the user set a specific speed. So something like this. Similar to how we programmed our first version of setting the speed in twelfth, we're going to let the user set a speed factor. It's always easier to talk about it in terms of a factor because now I can say this can be a value from 0 to 1, for example. Just like we did in our twelfth code, we don't want the user to accidentally say that the robot can go at 110% speed. And clearly it's complaining that this clamp function doesn't exist, and that's because in Arduino they define a function for us called constrain, which does something fairly sensible. You pass in a value, an amount, and if it's lower than the low amount, then it returns low. Otherwise, if it's higher than the high amount, it returns high. Otherwise, it just returns the value itself. Somewhat confusingly, we need to use these analog write functions to set the actual speed. So something like analog write for both PWM values. And what we'd like to do would be code that looks a little bit like this. Analog write, tell it the pin that we want to write to, and then actually set our factor. The term analog here just means it's not a digital value. It's not a binary value. Meaning theoretically we should be able to, for example, set the motors to some real valued factor, something like 50% speed. Behind the scenes though, analog write, if you look at the signature here, takes a pin and then it takes an integer value. If we go into the definition for it, you can see some code here making sure that we are not accidentally writing to some invalid pin number. And then it calls LEDC write. The LEDC bit here, if we jump into that file, is because PWM signals are often used to control an LED, a light emitting diode. So you can think of it as like a dimmer switch. If you set it to a low number, then the light is dim. If you set it to a high number, then the light is bright. And you can keep going down the rabbit hole of looking at the LED code and seeing that we pass in a duty, and it checks the range of the duty cycle, and it eventually sets LED set duty. Something easier to do for a built-in function like this is to actually just look at the documentation though. So for analog write, it expects you to give it a pin and a value. The pin is sort of self-explanatory. What pin do we want to output to? And the value is is a duty cycle between 0 and 255, where 0 is always off and 255 is always on. So jumping back to our motor control code, this factor here should be in the range 0 to 255, where 0 would be corresponding to our 0, and 255 would be corresponding to 1.0, or 100%. We could have the user pass in that value directly, 0 to 255, but I have trouble thinking in, what's 80% of 255. It's easier for me to pass in 0.8 for that. Luckily, we can use a function called map, which takes a long, another long, a long, and another long. If we look at the map function and look at the function signature for it, you can see it says it wants the value, and then the from range, and then the to range. So we're going to have our value, and the from range is from 0 to 1, and the to range should be from 0 to 255. I should match the signature. So since map is taking longs, I should also have the return value be a long. So again, this is what I would like it to do, is I would pass in a floating point number into the range 0 to 1, and it'll map that into the range 0 to 255, and pass that to analog write. This code has a pretty significant bug in it though right now, which is the map function takes longs. And when you pass in a floating point value, so for example this factor, it'll round to the nearest value. Or actually I believe it truncates it. I'd have to look up the C++ casting rules. But either case, this factor is always going to be either a value of 0 or 1, which is going to eliminate sort of everything in between. So what we really want from the users is for them to pass in something in the range 0 to 100%. Not my favorite API, but still more readable than saying, 200 out of 255. 200 out of 255, which is 78%. So still easier to say 78% than it is 200 out of 255. So let's call this a percent now. So the user is going to pass in a percent in the range 0 to 100. And honestly, the rounding error here is not going to matter that much. So I might as well change this to a long. 80.1% speed is not going to be that much different than 80% speed. Especially with feedback control, it's just not going to matter. If the user does give us a negative value or something over 100, we do want to get rid of those. So we do still want to call constrain. And now that we have a value between 0 and 100, and it's now a long, and I'm realizing no reason for these to be floats anymore, I can now map that into the range from 0, 100 to 0, 255, and write that to the motor. And here's another good place to make this name a little bit better. Let's call this the forward function, meaning it's going to go straight forward. Meaning we're going to apply the same duty cycle to both the left motor and the right motor. So now we have a decent little interface for controlling our motors. We have our pins defined. We set up our pins correctly. We call stop. If the WebSocket indicates that we should be disabled, meaning communication's been dropped, then we will stop our motors, which sets both to a duty cycle of 0. Another way to do this would be to set speed forward and pass in a 0%. But I think it's a little cleaner and better code documentation to just remember exactly what does it mean to say stop. And then finally we have our set speed factor forward, which will just make both motors set to the same speed and run them forward. For those that are curious, we'll eventually refactor this code so that they don't have to just be forward. It'll be just set speed factor linear, for example, and we could allow values from negative 100 to 100. And we'll use the negative value to set the direction pins instead of being low to high. And speaking of the direction pins, this would be a good time to introduce a new enum. And we'll call this the motor direction enum. So instead of specifying low here, it would be nice to specify forward or backward. And if I'm remembering how we wired our motors correctly, I should actually put these in the other direction. C++ by default will take whatever the first value in the enumeration is and set it to 0, as you can see by the little pop-up hover here. And the next value will just be incremented, so it'll be a 1. And that corresponds to low as 0 and high as 1. If I want this to be specified manually, I can manually specify them like this. And let's see, will my code formatter let me leave it that? No, it'll put it all on one line. I think it's a little more readable the other way, but the nice thing about a code formatter is I don't have to make those decisions. So I could specify those as 0 or 1, or I could specify them as low and high as just another way to remember that. The direction backward means low, the direction forward means high. And actually maybe a more sensible default is to set them forward as the initialization step. Alright, I think that's a good place for this video, except to say that we should make our motors drive. And I think the complaint here is I called it motor control in one place, and motor controller in another. Let's see, what's the error message here? These are inaccessible. So I need to say these are not private member variables or member functions, methods. These are things that users should call. And in the constructor, let's set them to 0.5, or rather 50% forward. Looking at the hover for this, the only place that we can see what the value should be is in the name of the variable, %. And the fact that it's a long means that it won't be a floating point value, so that's probably enough documentation. But it is tempting to change this to set speed % forward. I'll think about that in between videos and see if I want to make that change.